Hello, this is Mrs. Doro, and this lesson will be today on measurement techniques and how that we would like you to use a ruler, a triple beam balance, and a graduated cylinder. Anything that I star or make kind of look like a star, you're going to want to write down. There's probably more things that you may want to write down besides what I star, but what I star would be like your basic concepts. All right, so we will be checking these notes after you view them and copy them down. Measurement. Measurement is when you take a ruler and you measure the length, which is the distance between 2 points. Usually we're going to use a ruler. Unless we're measuring a long distance, we may use a meter stick. So if you look at the ruler below, there are two sides. This is the English side. Don't use that side. I'm going to scribble that side out. You want to use the metric side. We're always going to use metric. All right, starting at 0 and reading out. If you notice, it is in centimeters. You can see the little centimeters right there, and it goes by ones. Which one of the long lines is a 1. Then you have millimeters, which are the smaller ticks. All right, using a ruler isn't really hard, but kids mess up all the time, so you need to pay attention what units you use. You're going to end up measuring in inches if you don't pay attention. So we usually use centimeters or millimeters, so I have a piece of iron in the picture. And if you were to look at that, how many centimeters long is that and how many millimeters long? Those are the two questions that I have there. So once you take a look at that, put a ruler right up there, and as best as you can, take a look at what you think that would be. And then look at the little monkey. Oh, he's so small. And I want you to look at how tall he is, starting at 0 centimeters and reading up. What would your answer actually be? Because on the next slide, we're going to look at how I would like you to measure them. Okay, so when measuring with a ruler, you may look at it and you may say, oh, it's about 7.5. But we're not going to estimate. We're going to try to be as precise as possible. Centimeter lines are labeled by the ones, so we're going to see how many centimeters and how many millimeters our piece of iron is. First, we're going to look at centimeters because they're labeled 1, 2, 3, 4, 5. So if you look at this piece of iron, it looks to be, here's 7, right here. It looks to be 7 point, each dash beyond that is going to be a point. So 7.1, 2, 3. I don't know if it's quite to the 4. I would say it might be. So 7.4. But we're not going to stop right there. We're going to see, is it right on the 4? Or is it, now there's a little bit of where it comes out right there. So I would say it probably is on the 4. If it is dead on one of the lines, then you're going to go one more place, you're going to put a 0. If it's not dead on the line, and that would be centimeters, then you would write 7 point, let's just say it wasn't quite to 7.4, it was 7.3 and a little bit. 7.3, you put a 5. You're either going to end with a 0 or a 5. It's either dead on or it's not dead on, and that would be centimeters. Now millimeters, there's 10 millimeters in 1 centimeter, so basically we're looking at 1 centimeter being 10, so 10, 20, 30, 40, 50, 60, 74 millimeters, and you're going to write that with one place past the decimal, so you would say 74.0 millimeters, or if it's 7.35 centimeters, it'd be 73.5 millimeters. 0.5 millimeters. You're always going to end in either a 0 or a 5, depending on if it's right on the line or if it's just a little bit over. Our monkey, I would say, going from the bottom where his tail is, starts at 0, and I would say he is pretty much a little bit over the 8. All right, so I'd say he's about 8.1. All right, and I'd say he's just about right at 8.1. So I'm going to say 8.10 centimeters, which would be 81.0 millimeters. Okay, you're going to be doing a lot of measuring in your lab, so you need to make sure that you're using the right side and that you're keeping your millimeters and your centimeters straight. This takes us to graduated cylinders, where you measure liquid volume, and it usually increases by milliliters. You can see for our milk lab, I had the milk in a graduated cylinder. You can't see the lines that well. I did label some right here, and they're usually on the right-hand side. You will see numbers on the left-hand side. Graduated cylinders have labeling on both sides. You want to go from 0 at the bottom up. and you want to measure usually to the 10 spot using a 0 or a 5 for your tens. As you notice, the difference between 59 and 60 to the picture on the right isn't very much. So if I were to look at the actual milk, I have two lines drawn. One is red, showing where the 60 milliliter line mark is, and one is yellow. The yellow shows a dip. Then the milk will dip down because of the way the plastic is. It's the meniscus. The liquid actually will kind of dip down, and that is where you're going to measure at the bottom of that meniscus. So where it says 59, that's where you're going to actually report your reading. And that wouldn't just be 59 milliliters, that would be 59.0 milliliters. You're either, again, going to go with a 0 or a 5. If it's right on the line, you would go 0. If it's not right on the line, you would go 0.5. When you have something that is irregularly shaped, you're going to find it by using something called water displacement. You fill your graduated cylinder up to a certain level, and it doesn't really matter how much, you can decide that, and it has to be enough to cover the object, obviously. And then you put the object in this instance it's a key, and you see how much the water rises. That difference in the water rising right there, that is actually your volume for that object. Now, granted, right here, if you have an object that's small enough to fit, it has to be able to fit all the way in the graduated cylinder, and it can't float, or else it won't do you any good. Okay? So, you have to have a small object, and you're going to take the difference between where the water level was and where the water level goes up. Triple beam balances measure mass of an object to the 100th of a gram, and so you can be very specific as far as the object that you're measuring. The goal is to get the lines to match up, and you can see right here there are two lines, and if they're even, that means you have a balanced triple beam balance. So you have the right mass, and then you have to figure out by looking at where you move the weights over, what mass that would be. A triple beam balance works by sliding weights over in their slots in the hundreds, 10, 1, and tenths places. If you notice the first one, there's a notch right here. You need to make sure that you're in the notch when you go to move your weight. You don't want it to just be sitting there. You would start with your hundreds if you think it weighs at least 100 grams. If not, then you would start with your tens. And you're going to look to see if your line is above, then it's not heavy enough. If it's below the line, then it's too heavy. And so you're going to move all three of the large amounts. Then you're going to look at this little tiny amount down below here, and as you can see, it's labeled 0.1, 0.2, and you can go to the hundredths, and you can round actually to the thousandths there. So start by estimating what you think the mass will be, and then you're going to start with the heaviest in the back and work your way forward. So reading the scale will be the total mass of the object if you look at where the arrows are pointing. It looks to me like we have 137. So 137. This is our decimal now. We are at 0.5, but we're past 0.5, so it's 0.5, but we're not quite to 0.6, so we have to look at each individual line. It's in the hundredth spot, so it looks like we're past 0.55 to 0.56. So it would be 137.56 grams. Again, being able to read a triple beam balance, what is the mass of this beaker of water? If you take a look, we have 260. If you can't read that, that's 260. We have 0 right here, so no 10, so it's still 260. So we're at 260. Now let's see what's after our decimal. We're past the 0.9, but we're not quite to 10 grams, so every little line, we're going to go 0.9, 1, 2, looks like about 3, 0.93 grams. That's how specific you need to be. You need to make sure that these are lined up these two lines are lined up when you go to record your measurement. Last but not least are some things like temperature. All right, to measure temperature, obviously, you read with a thermometer. I think most of you have used a thermometer many, many times. So we're using metric. We're using metric, so we're going to use Celsius, and you're going to go to the nearest tenth. So if you look at the thermometer below, what is the temperature? In a normal room, you'd say, oh, well, it's about 74. But you're going to look on the right-hand side where it's Celsius, and you're going to look in the 20s. It's past 20. It looks like it's about 24, but we're going to go to the 10th, 0.0 degrees Celsius. The next step on this slide talks about volume and area of a solid. Just did a real quick refresher. You should know this from your math class and from physics, physical science. And so looking at volume, there's kind of my star right there, of a solid. You're going to go length times width times height, and you're obviously going to use centimeters or millimeters depending on how large the object is. To find area, we are going to use, again, a ruler, but we're just going to do length times width. So if we use centimeters again, we have different units here. Volume, length times width times height, you have a centimeter times a centimeter times a centimeter, which is going to give us centimeters cubed. You have to make sure you have that cubed in there or it's not the same thing. For area, it's a centimeter times a centimeter, which gives us centimeters squared. You're going to be using all of these units on your measurement lab come Wednesday.